Be on the lookout for these triangles, especially when taking the SAT or ACT. These are going to be special triangles that could be treated as shortcuts to help you solve problems. We have the 45-45, which references the two angles inside. We also have the 30-60. That's the 30-60. Again, referencing the two angles inside the triangle. All of these are right triangles, by the way. The other triangle that we're going to focus on at the end of this video is the 3-4-5, which has nothing to do with the angles and everything to do with the sides. Now, what's important about these triangles is how you can determine the sides of the triangles based on these angles. Let's focus on these two first, the 45-45 and the 60-30. So with the 45-45, the format of every single 45-45 triangle looks like this. We have the length of the two legs being exactly the same. And then the hypotenuse is going to be whatever the length of that leg is times the square root of 2. So if we know that x is 3, then the hypotenuse is 3 square roots of 2. And this saves us the trouble of doing the Pythagorean's theorem and solving for that hypotenuse. We can save a lot of time being able to recognize this special triangle. Similarly with a 30-60. It's a little bit different with the proportions. Here's how they look. We have the shortest length leg, the shortest side, which by the way is always across from the 30-degree angle. That is going to be x. That's our x. Now we have another leg. It is longer, okay? And this is going to be x square roots of 3. A little bit different than the square root of 2, but it's easy to remember the square root of 3 because there's a 3 in the angle. That's what I use to help me remember whether or not it's x square roots of 2 or x square roots of 3 for the 60-30. Now for the hypotenuse, it gets a little bit easier. It's always going to be 2x, which is twice the length of the small leg. So this might look kind of confusing or overwhelming, but we're going to practice this. I'm going to break this down further. The 3-4-5, we'll get back to that at the end of the video. Let's start off with some practice problems for the 45-45. It may not look perfect, but these two sides are the same length. Let's label the hypotenuse y, and let's say if x equals 7, find y. Alright, so we don't have to plug 7 into the triangle at all. We know that y equals x square roots of 2 because these are 45-degree angles. And I apologize, that would be given to you. They would give that to you, 45-45. Or they might say, if the two legs are the same length. If they tell you that the two legs are the same length, you can infer that we have a 45-45 triangle. So those are very telling details that help you create or build a triangle. Let's continue. So we know that the hypotenuse y is equal to x square roots of 2, and we know that x is 7. So my answer is just 7 square roots of 2. All right, let's start from blank again. Let's do another one. Let's go and let's say y, if let's say y equals 25 square roots of 2 in a 45-45 triangle. All right, so we could construct this. Label the two legs as x. They told us that it's a 45-degree angle. And they told us that y, the hypotenuse, is 25 square roots of 2. Well, what do we know about the relationship between the hypotenuse and the legs? We know that the hypotenuse is going to be equal to x square roots of 2. We also know that y is a certain number, 25 square roots of 2. It's not a pretty number, but we know that we could just substitute the letter y for the number that they gave us. Okay, so building this equation is very important, and all I'm doing is I'm remembering the rules of a 45-45 triangle. We have 25 square roots of 2 is equal to x square roots of 2. So essentially we want to solve for x. And so what would you do to solve for x? Well, we would want to divide both sides by the square root of 2 because we want to get x by itself, and we could cancel out this radical. Well, thankfully, on the left-hand side, the two square roots of 2 also cancel. So we have 25 equals x, and that's our final answer. Find the length. I'm sorry, I never finished the question. Find the length of a leg. So that's how you could find these different sides. Let's keep going. We have some more practice problems for the 45, 45. What if y equals just 25? Y equals 25 finds x. And let's say they give you a diagram. All right, so they don't give you everything. But here's what you can infer just from this diagram alone. We have one angle that's 45 degrees. Now we know that an angle, or all the angles of a triangle, add up to 180. We have a 90-degree angle. That's that little square. That little square always indicates a right triangle, which means that that's a right angle. We have a 45-degree angle. That's what they told us. They gave us that. And then we have an unknown angle. Let's call that angle A. Let's give it a capital A. So knowing the shortcuts, we can already tell this is a 45, 45. But let's just practice the math real quick. We get 180. If we subtract 90 to both sides, we get 90 equals 45 plus A. And then I would subtract 45 to both sides. So I just proved that my missing angle is also 45. They didn't have to tell me that. I'm going to use my blue marker for that. That's something that you can infer as a student, that this other angle is also 45 degrees. And once you get comfortable with it, you don't have to do all this math. You don't have to prove this every single time. I just did that one time so you can see where I got the numbers from. You can always infer that the other angle is 45. So this is very helpful because now I could also infer that the other side, the other length, is x. Now they're only asking to solve for x, but what we can now recognize is that this hypotenuse is x square roots of 2. They didn't give us any of that information in the blue ink. We had to actually determine that ourselves. Well, we know that y is 25, and it's equal to x square roots of 2. So we want to solve for x, right? That's our goal. We have the equation. Now we could do it. We could solve. Divide both sides by the square root of 2. Now we have an issue, though. We have a radical in the denominator, and you are not allowed to keep it that way. You're not allowed to have a radical down below. So what you want to do is multiply the top and bottom by the square root of 2. Whatever radical you have down below in a fraction, multiply that to the top and to the bottom. Your result is going to give you the same number down below, just without the radical symbol. And then up above, we just want to multiply the 25 with whatever that radical is. We could just connect those. We could put those right next to each other. So that's our answer. X equals 25 square roots of 2 over 2. It's not pretty, but we did all the math correctly, and that would be our answer. All right, let's see. Let's do one more for the 45s. Say they give us another diagram. Whoops, that does not look at all like a 45. There we go. Let's say they measure, or they give the measurements as A and B for the angles, but they give us the length of every single side. All right, so 5 square roots of 2, and they say finds the measurement of angle A. All right, now if we did the math that we practiced just a little bit ago, we have a 90-degree angle, an unknown A, and an unknown B, which means we can't solve. We can't solve using this type of math, basic algebra. We can't actually do that. You have to be able to recognize that we have a pattern here, and the pattern matches the 45-degree angle triangle. Once you recognize that, you can see that the x value is 5, and then you can understand that the measurement of angle A must be 45 degrees. So being able to recognize this pattern can help you in a lot of ways, because they could then take this into turn this into a more advanced problem, like what the SAT and ACT like to do, and they like to implement this shape right here into a larger figure, into a larger diagram. And they won't tell you anything about this piece, but you have to be able to understand and recognize and identify that this is a perfect 45-45 triangle. So I could tell that both angle A and B in this instance are both 45 degrees. All right, so let's take all of that information that we practiced and let's translate it into a 30-60 triangle. So with 30-60, the process is similar, but before we just jump into practice problems, I want to go over something pretty briefly, and I touched up on it a little bit ago. When drawing this triangle, I'm going to draw one, and then the next one I draw, I want you to pause the video and try it on your own, because we could draw this horizontally and vertically. So I want to explain the position of the angles. It does matter. You can't just put 30 here and 60 here. You can't just put them wherever you want. The 30-degree angle has to be across from the smaller side. Whoops, the smaller side. And then we know that the smaller side is always x. You don't want to put the longer side as the x value. Now, if this is catching you off guard or if you're getting stuck on this, understand that we have x times the square root of 3. Okay, you don't have to understand what the square root of 3 is, but if you multiply x by a number that's greater than 1, it is going to be a bigger number. And the square root of 3 is bigger than 1. It's about 1.6, 1.7, 1.7. Anyway, so when you multiply this, you're going to get a larger side. So this needs to be on the longer side. Furthermore, you have the 30 across from the small side. The 60-degree angle should be across from the larger leg, the larger side. The largest size, the hypotenuse, is always 2x. So that part's easy. All right, so here we go. Let's draw it vertically. Pause the video and try this on your own. Try filling out this diagram on your own. So the short side is always going to be across from the 30-degree angle. The larger side, the larger leg, I should be saying leg, I apologize, is always going to be across from the 60-degree angle. When filling in the sides, x is the smallest, x squared to 3 is the next step up, and then the very last step, the largest leg, is twice the smallest. It's 2x. All right, so let's keep this on the board and do some practice problems. We have if the height of the triangle above, let's focus on just this triangle, of the triangle is 10 inches, finds the hypotenuse. So the height is going to be, in this case, in this diagram, the height is the smaller leg. Now, I don't know much else about it other than the angles. We know the 30 degrees and 60. So I can't use Pythagorean's theorem to solve for the hypotenuse. I would have 10 squared plus an unknown side squared equals c squared, right? We don't know the other side, so we can't solve for the hypotenuse doing that. We have to understand that the proportions here tell me that the hypotenuse is going to be 20. It's going to be 2 times the smallest side. And that's my answer. Hypotenuse is 20. Once you get comfortable with these, the questions become really easy. They can be done very quickly. And it does take a lot of practice to get comfortable with it. So moving on to the next question, we have if the base is 12 inches, find the height. All right, so now we're involving this other leg and relating it to the other. So we have x square root of 3. That's our base. I'm going to put that in quotes. I want to show you how I interpret the words into an equation. So the base is equal to 12. With this equation that I derived from the word problem, I could solve for x. If I divide both sides by the square root of 3, I get 12 over the square root of 3. And like I said, we can't keep that in there, so we have to multiply the top and bottom by whatever radical is down in that denominator. This is going to leave us with 12 square roots of 3 over 3. Now we're looking pretty good, but we're not done. Since we have multiplication on the top, no addition, no subtraction, we can simplify the fraction. We can simplify the 12 and 3. 12 divided by 3 is 4. So my real final answer is 4 square roots of 3. But what do we solve for? We solve for x. Does that satisfy our question? What are they asking for? They're asking for the height. So let me grab my other marker. Our height. In our case, what is the value of our height? It's whatever x equals. They told us the length of the longer leg, and they wanted us to find the length of the other leg. Thankfully, the length of the other leg is just x. So I made sure that we solved for the right side. We solved for x, and we solved for the height. So that's our answer, 4 square roots of 3. You might ask yourself, well, what happened if they say, find the hypotenuse? Sure, we could do that. We did all this work properly. You would have had to done all this work anyways if you had to solve for the hypotenuse. But then think about what you would have done next. If they're asking for the hypotenuse, that's going to be the 2x value, isn't it? We know that the hypotenuse is 2x. So it's important that we solve for x, but that's not our final answer. If we had to find the hypotenuse, we would have to double it. So it'd be 2 times 4 square roots of 3. Double it and give it to the next person. X equals 8 square roots of 3. All right, that would be our hypotenuse. So that solves both of those types of questions there. Get comfortable setting up the equation. I think that's what's going to help a lot of people, a lot of students, is being comfortable setting up the equation. Let's see what we have next. It says if the hypotenuse of a 30/60 is 84, let's say inches, find the length of the longer leg. And in this case, they don't give you any type of diagram, so let's make one from scratch. All right, it doesn't matter how you orient this. If you want to make it long ways horizontally or vertically, does not matter. Doesn't change our answer at all. Whatever you're comfortable with. There's my base. I know it's a 36. That's my basic shape right here, and the hypotenuse is 84. They want us to find the length of the longer leg, so that's this length right here. I'm not gonna label this x, okay? Oh, voice crack. My instinct was gonna push me towards labeling this x, but knowing the format of a special triangle, the 30/60, this shorter side should be x, the longer side should be x square roots of 3. All right, so what do I know about the value of x? I know that x, I know that the hypotenuse is twice the length of the short side. The hypotenuse is twice the short leg. I want to reiterate, I know this because it's a 30/60. Only because it's a 30/60 triangle. That's the rule here. So if 2x is equal to 84, right, the hypotenuse is 84, then I know that x is 42. I could do that by dividing both sides by 2. Now that I know x, I can find the length of the longer side really easily. All I have to do is input my value, 42. So we have 42 square roots of 3. And that's it. That's our answer. If you have multiple choice options that have a bunch of decimals involved, then just use your calculator. You won't be expected to do this by hand. You won't be able to expect it to actually multiply these two values by hand. This is a proper final answer, by all means. But just in case you're stuck on your homework or something like that. On the SAT, ACT, they're probably going to have it in this format. All right, so great job so far. Let's see. Let's do one more with the 30/60. 5 square roots of 3, and then 10. Let's label these angle A and angle B. Find the measurement of angle B. So I labeled out a diagram for you. Didn't give much information about it, but hopefully you can recognize the pattern within the sides alone. You see how this value is also translated to the other leg as x square roots of 3. And then the hypotenuse is twice the length of the smaller leg. I know the diagram isn't beautiful, but as long as you notice that pattern, you understand that angle A is 30 degrees and angle B is 60. So in case I lost you at this part, labeling which one 30 and which one 60, remember, this 5 is smaller than 5 square roots of 3. The 5 is smaller. So the 30-degree angle needs to go across from this side. See that? The angle does not correlate with the side that it touches. So to finish the answer, the measurement of angle B is 60. All right. I believe this gives a lot of students a hard time because it's very different from all of the basic algebra concepts and even geometry concepts that we practice to solve for these values. Let's move on to the 3, 4, 5 triangle. So with these triangles, there's no angles required in terms of understanding what's needed to solve for the sides. That's what makes this triangle very interesting. Furthermore, it can be scaled up. So let's do a quick practice problem here. If we know that one leg is 3 of a right triangle, and then the 4 is the other leg, we know automatically that 5 is the hypotenuse. Let me prove that. So if we use Pythagorean's theorem, we would do 3 squared plus 4 squared equals c squared. Before you roll your eyes, don't worry. You don't have to do this all the time. That's the purpose of this special triangle. We take the square root of both sides, right? That's our last step. So the square root of 25 equals c, which is 5. All right, it's not a coincidence that we got a perfect whole number. This ratio of legs, the long leg and short leg here, will always give you a perfect whole number for your hypotenuse. That's what makes these triangles interesting. I don't know anything about the angles necessarily, and you don't need to, as long as you recognize this ratio. So let's do one more where I change the numbers up. I want to see if you can recognize it. Let's face it the other way. Really throw you guys off here. All right, guys, what's the hypotenuse? Okay, you don't need to use Pythagorean theorem to do this. We know that 3, 4, 5 is a special ratio, right? And these two lengths are the legs. Sorry, that's off screen a little bit. I can scale this up to 6, 8. Any guess for the last number here? 10. Which means without doing any actual math, my hypotenuse is 10. Every time. As long as I have these two sides as my legs of a right triangle. So let's put this into an actual word problem. If we have before we do a word problem, let's do this. 4x and 5. X equals what, guys? What do you think x equals? I'm sorry my picture isn't proportional. I should have made this shorter. But x is 3. All right, follow the rules here. We know that 3, 4, 5 is a special triangle. The placement matters, particularly with the hypotenuse. If I had something like this, let's see. Well, no, that'd be impossible anyways. All right, scratch that. Let's move on to an actual word problem, and then we'll finish up. If you have a yard that's 80 feet by 60 feet, like a backyard, find the length of a sidewalk or a pavement, a paver, a paved path connecting the two diagonals. Connecting the two corners. Opposite corners. Okay, so let's draw a rectangle. We know it's 80 by 60, and we want to connect the two corners. I know that 3, 4, 5 can become 6, 8, 10, and now we just added another digit. So 60, 80, 100. My hypotenuse is 100. All right, so I know that the paved path is 100 feet. All right, guys, I hope this video was really helpful for you with special triangles. Feel free to recommend any topics in the comment below. Subscribe for more free math. And thank you for supporting the channel.